So 5 minus 3i is a root. We need to find the polynomial that has that as a root. So since 5 minus 3i is a root, and you know that imaginary roots always happen with their conjugates, 5 plus 3i is also a root. They always happen with their conjugate. So to multiply this out, you'd have to write it as x minus the root. So x minus 5 minus 3i and x minus 5 plus 3i. You need to write them out so you can multiply them together. Since they are conjugates, you can use that shortcut, MAM. Multiply the first items, the first terms. X times x is x squared. Add the middle term, negative 5 and negative 5 is negative 10, and put an x on it. Multiply the middle term, so negative 5 times negative 5 is 25. And then multiply the last term. Negative times positive is negative. 3 times 3 is 9. I times I is I squared. Since that's I squared, it's negative 1. Cross it out. Change the sign. So now we have x squared minus 10x, and we can combine our 25 plus 9 is 34. So there's the polynomial with 5 minus 3i as a root. It's the exact same pattern for this because it is an irrational root. They also happen with their conjugate. So 3 minus square root of 5 is also a root. And then we write it as x minus 3 plus root 5 and x minus 3 minus root 5. And we can use the same MAM shortcut because they are conjugates. So multiply x times x, x squared. Add negative 3 and negative 3 is negative 6. Put an x on it. Multiply the middles. Negative 3 times negative 3 is positive 9. And multiply the backs. Negative 5. Combine those like terms, you get x squared minus 6x, 9 minus 5 is 4. So there's our polynomial. Here's another similar question. It's just slightly different because they give a couple more roots. So we know 5 plus 2i is a root, which means 5 minus 2i is a root. So x minus 5 minus 2i. X minus 5 plus 2i, and then 3 is a root, so that's x minus 3, and 0 is a root, so that's x minus 0, or you could just say just regular x. And then multiply all those together. So pick 2 to multiply together. I would pick the first 2. Multiply the conjugates together, use the MAM shortcut. X times x is x squared. Add negative 5 is negative 10x. Multiply negative 5 and negative 5 is 25. And then multiply negative 2i, positive 2i is negative 4i squared. Cross it out, change the sign. So that's plus 29. And then we're going to multiply that with x times x minus 3 is x squared minus 3x. And multiply those together. So x squared times x squared x squared times negative 10x, x squared times 29, negative 3x times x squared, negative 3x times negative 10x, and negative 3x times 29. Combine like terms, so our x cubes, and oh, that should be squared. And combine our x squareds. So x to the fourth, negative 10, negative 3 is negative 13. 29 plus 30 is 59. And then minus 87x. It's all multiplied out, so that's our answer. So another very similar question. Irrational roots like square root of 3, those will also happen with our conjugate. So if square root of 3 is a root, so is negative square root of 3. If negative 3 plus I is a root, so is negative 3 minus I. So that's x minus the square root of 3, x minus negative square root of 3, so x plus square root of 3, x minus negative 3 plus I, and negative 3 minus I, and these both are conjugate pairs, so we can use the MAM shortcut. So we multiply x minus 3, x plus 3. We actually don't need MAM because it's just a difference of squares pattern. That's x squared. Square root of 3 times square root of 3 is just 3, and it's negative. Then on the other side, we'll use MAM shortcut. So multiply, you get x squared. Add, you get 6x. Multiply 3 times 3, you get 9. And I times I is I squared. So it's negative I squared. So that's negative 1 turns to positive 1. And now we need to multiply those two answers together. X squared times x squared times 6x, x squared times 10, negative 3 times x squared, negative 3 times 6x, and negative 3 times 10. Combine like terms. You get 7x squared. And there's the polynomial. The remainder theorem essentially just says that rather than plugging in negative 2 and doing all these powers, you can do synthetic division. With a negative 2. And the remainder would be the answer. So check the powers, 5, 4, 3, 2, 1, constant, nothing's missing. So that's 1, negative 1, negative 1, negative 1, negative 1, negative 1. Do the synthetic division, so add, multiply. Add, you get negative 3. Multiply, you get 6. Negative 10, negative 11. Positive 22. Minus 1 is 21. Times negative 2. Add, you get negative 43. So the remainder is negative 43, which means the answer or the output is negative 43. F of negative 2 is negative 43. So listing all the possible roots, P over Q. P is the constant, Q is the leading coefficient, and it's all the factors of those numbers. So 6 over 3. It's all the factors of 6, which is 1, 2, 3, and 6, over all the factors of 3, which is 1 and 3. And it's all positive or negative combinations of those numbers. So you can have 1 over 1, 2 over 1, 3 over 1, 6 over 1, or any of those over 3. 1 over 3, 2 over 3, 3 over 3, but that's just 1, and we already wrote that. And then 6 over 3, which is 2, and we already wrote that. So there's all the possibilities. Plus or minus 1, 2, 3, 6, 1/3, and 2/3.